Hello and welcome back to the A-Level or AS Year 12 prep work series. Today we're going to be covering factor theorem and algebraic division. As always, there is a link to the PDF in the description. I've uploaded it to Patreon because it's just easier to save space, but you can access it completely for free. So feel free to download that after the video or right now. Have a go or use that worksheet as practice because you're going to have all of the answers on this video. So, factor theorem and algebraic division are two really important topics. One, because they're actually worth quite a few marks. As you can see, this is a 6-mark question straight away, which is really useful. But also because we're going to be using algebraic division in multiple topics in the future, in things such as partial fractions, integration, and differentiation. And they'll make your life a hell of a lot easier. So that is kind of, in a nutshell, why this is really useful. So the algebra video that we did last time and this one, two vitally important skills, and they're both to do with algebra, so it shouldn't really be much of a shock. So, first of all, it says for part A, use the factor theorem to show that x plus 3 is a factor of g of x. Now, this is just what the factor theorem is. The factor theorem simply states that if x plus a is a factor of f of x, then f of a, of minus a technically, is equal to 0. That's what the factor theorem states. Technically I should have probably written this backwards. So if f of minus a is equal to 0, then x plus a is a factor. And we have to just ask ourselves why that's important. So the reason why this is important is it's actually going to give us the ability to factorize things that are bigger than x squared. So any kind of polynomial meaning anything with x squared, cubed to the 4, etc., we'll be able to factorize it using the factor theorem and algebraic division. Okay, those are two really important things. Okay, so hopefully that makes sense. So if x plus a is a factor of f of x, then f of minus a is equal to 0. You can write that completely backwards too. So if f of a equals 0, then x minus a is a factor of f of x. Okay, so it works both ways, of course. In this case, though, we're using this first line. So they're saying that we need to use the factor theorem to show that x plus 3 is a factor of g of x. Well, if we have a look at this first line here, they're saying if x plus a, where a is equal to 3, is a factor of f of x, then f of minus a, so minus 3, should be 0. So what I'm going to do is I'm going to sub in minus 3 into this equation and see if it equals 0. Now, of course, we can just use our calculators. So you might wonder where on earth the 2 marks come from. Well, the first mark is for obviously knowing the factor theorem. So you can either write it or imply it. So I'm going to show you this here, this top part, well, I was about to say top part at the top. That's a bit of an obvious, pointless thing to say, isn't it? That bit at the top is not actually part of the answer. Here's what I would do as my answer. I would do this, find what it equals to, and then that would be 1 mark. So if I whip out my calculator, let's put it on the calculator. Minus 3 cubed, minus 8, minus 3 squared, minus 35, minus 3, and lastly plus 75. And indeed we get 0. So here's what you would write. So equals 0 gives you 1 mark. Then you have to write something that implies that you know that this means that x plus 3 is a factor. So then you could say something like, therefore, x plus 3 is a factor of g of x. And that's all you need to write for 2 marks. Super easy and quick 2 marks. Okay? Now for part B, it then says hence show. And remember what I said in the first video, I tried to hammer it into your brains. Hence means you have to use part A. Now, let's think what this means. Well, it tells me that what this factor theorem tells me is that x plus 3 is a factor of g of x. But remember what a factor is. A factor is something you can divide a number by. So what they're saying is, in this case, I can factorize out x plus 3. And then I get something inside the brackets. But how do I work out what's inside the brackets? Well, that's where it gets a bit tricky, because I have to divide this expression by x plus 3. And I'm going to show you how to do that right now. Now, this is going to seem like a bit of a long, tedious process, but it's actually quite simple. And as long as you follow the steps carefully and lay your work out neatly, so as you can imagine, I struggled with this when I was in year 12, you'll get the answer right every single time. And again, this comes back in A2 as part of a question. It will say integrate this, and you'll have to do algebraic division first. You have to use the factor theorem, algebraically divide, then integrate. Okay? So, let's do it. Well, as you might imagine, whenever we do long division, we use the bus stop method, and it's no different here. So my divisor, the thing I'm dividing by, is going to be x plus 3. And I'm going to do the bus stop. Again, this might take you back to GCSEs. And then I'm going to write everything I'm dividing this thing, well, what I'm dividing, right? So minus 8x squared. And what I want to do is actually space it out quite a bit. Again, just like in long division, you're going to leave yourself a bit of space, because we're going to be doing quite a bit of juggling, okay? Now, how does this work? So I'm going to show you this first step, and then all you do is you repeat it until you can't anymore. Just like in long division. Remember what you do in long division when you had something like 3 and you tried and divide, let's say, 210, right? You try and divide 3 into 2, and then you repeat the step for every single digit, don't you? It's similar in this case, however, of course, I mean, I can't just say how many times does x fit into that. So what you do is you take the first term here and you divide it by x. So 4x cubed divided by x will give me 4x squared. So I'm going to put that above the x squareds. Cool so far? Then you times what you just got by both of these things. So 4x squared times x gives me 4x cubed. Now I can imagine some of you feeling a bit weird about this, because what I've just done is divided by x then times by x. So that will never give me a different answer. You're starting to get it. You're 100% right. This first term is always going to be the same as the previous term. And that's the idea, because you're reducing it every single time. How do you know when to stop doing division? When you can no longer divide it by this first term. So if I get to, let's say, 4, I can't divide 4 by x, because there's no x to take away. That's when I would stop. Okay, 4x squared times 3. Well, 4 times 3 is 12, so I'm going to put the 12 here. And then x squared. Cool. Now here's where things get a bit interesting. You subtract. So I'm going to draw a straight line going along. And you subtract these two lines. Now, the subtraction is really important. It has to be subtract, because as you can see, we have negative numbers. So I'm sure you're aware of what happens with some students. They might have a negative number here, and they actually subtract it instead of adding, because minus, minus, right? So that's why I always write the negative sign here, the takeaway sign. So I know in my brain I need to minus. I can't mess that up. So 4x cubed minus 4x cubed, of course, is 0, so I'm not going to write it. Minus 8x squared minus 12x squared would give me negative 20x squared. And then if you notice, there's nothing under these two. Two ways to look at this. One way is you can say it's minus 35x minus nothing, which of course is minus 35x. And then 75 minus nothing, which is 75. There are some people who like to just draw a line going down, implying that you just carry it along. If that's confusing, then we can just leave it as, well, they're minusing nothing, right? Cool. Then what do? We repeat the process again. So that's what I mean. We've actually done algebraic division. I've taught you it. Now you do it again and again and again until you either have nothing left or you can't do it anymore, in which case you have a remainder. And I'll discuss with you how to do remainders in a later video, or maybe in this worksheet if it turns up. But we'll discuss it later, okay? Normally that might be left for integration, because obviously if you get 0, then you don't really need to integrate. Anyways, so minus 20x squared divided by x gives me minus 20x. And then again, I'm timesing it by x again, so I get minus 20x squared, as intended. And then minus 20x times 3 is minus 60x. What do I do now? Again, I do the subtraction. Again, I'm going to write the minus sign. Minus 20x squared minus minus 20x squared will be minus 20 plus 20, so 0. Minus 35x minus minus 60. If you're unsure, just use a calculator, right? So minus 35 minus, oh, hold on. Minus 35 minus minus 60, 25. Does it for you. You don't have to worry. And then again, this 75 is minusing nothing, so plus 75. Cool. 25x divided by x gives me 25. Multiply that again by x, you get 25x. 25 times 3 is 75, and oh look, that's perfect, because when we do the subtraction now, we're going to be left with big fat 0. This right here is my remainder. Now, if you think about what this first part said, x plus 3 is a factor of g of x, which means we know it can divide with no remainder. So we should expect there to be no remainder, which is why I said we're going to discuss remainders in a future video, because in theory, in this video, there shouldn't be any remainders, right? Because everything we're doing the factor theorem, which means they're going to be factors, which means there's going to be no remainder. Okay, so here's an exam tip. If you use the factor theorem in the first part and it says hence, and you get a remainder, you've done something wrong. Because if it's a factor, it must have no remainder. Factors of 16 are 2, 4, 16 and 1. If I divide them, I get no remainder. Cool, so then what do we have now? That's a really good question. Well, we have x plus 3 and we have this top thing. So I can now write g of x. So instead of that long expression down here, 4x cubed minus ax squared, blah, 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 we have the factor, which is x plus 3, and 4x squared minus 20x plus 25. And I'm going to explain it now, because think about what we've just done. We've divided 4x cubed minus ax squared minus 35x plus 75 by x plus 3. So effectively, we factorized out the x plus 3. And that is what's left over. So now we just need to factorize this last bit. And there's a bunch of different ways that you can factorize it. Again, it's completely up to you. You can do the good old-fashioned multiplying method, or you can do, whatever method you so desire. So I'm going to go through kind of what I believe is the most common method. There is a faster method for factorizing quadratics, which maybe I'll do like a little separate mini video on that. But in this case, you have to find two numbers that times to 100. Why did I get 100? Simple, because you have to times the first number, so the number before x squared, by the number at the end. And that gives you 100 and adds to minus 20. Now it's interesting. It times is to a positive number, but adds to a negative, which means both of my numbers are negative. So the actual solution is minus 10 and minus 10. So all we're going to do now is write it out fully. So x plus 3, we have 4x squared minus 10x plus 25, which means we're going to actually have a duplicate bracket most likely. And we can pull out 2x. Again, if you have a faster way of doing this, that's completely fine. I'm just showing the way that I believe most people would be familiar with. So that should be a 2, that should be a 5. That should just be a 5. There we are. And that'd be 2x minus 5. As you can see, these two brackets are the same, which is intended. So my actual answer is 2x minus 5 as my first bracket. Hang on, I've made this a bit messy. Let's just quickly redo that. So we have 2x minus 5 as our first bracket. And we have these two duplicate brackets as our other bracket, which is 2x minus 5. Now if we have a look at the actual answer, it says ax plus b squared. So all we're going to do is, since they are duplicate brackets, we can just write that as 2x minus 5 squared. Another time when this is really useful is we're going to be factorizing cubics. So cubic is where it has x cubed in it, quite a bit in the sketching graphs section of your course. So you have to sketch a bunch of cubic graphs, and you need to be able to factorize them in order to work out what their general shape is and where they cross the x-axis. So this is a really vital skill to get good at. If you're still unsure of kind of factorizing quadratics, that is something I would definitely focus on. So as usual, things are never always that simple. Here we have a 6-mark question where it just says use the factor theorem and factorize f of x completely. So if you notice in the previous questions, they gave us what the factor is, right? In some questions they may not give it to you. They may just say, hey, use factor theorem and work it out. So what do you do? Well, what you need to do is you need to start subbing numbers in until you find one which makes this whole expression equal to 0. So if we whip out our calculator, like so, we're going to just start with, I like to start with just the number 1 sometimes, just to make it, I mean, no particular reason, you can start with anything. And you don't need to actually write out all of these values. You can just do it on your calculator and just write down the one that actually works. So if I look here, that's just minus 12. So if I say that f of 1 is just equal to minus 12. Okay, so now we've got that. What we're going to do is we're going to make it a bit bigger. We're just using trial and improvement to work out what the value is. Just go through and delete and change it all to 2. And if you notice, the number gets more negative. So, what do I know about that? Well, I'm heading in the wrong direction, aren't I? I should be making this number closer and closer to 0. So let's try the opposite way. Let's go to f of 0. Now again, you don't need to actually write out all of these values here. You can just do it yourself. Now if I do f of 0, can you see it's just going to be 10, right? So I don't even need to write that one down. That's heading in, more or less the right direction, I suppose. So let's try minus 1. Keep going through. Keep going through. That gives me 18. And lastly, let's try doing f of minus 2. So if we go through and change this to a 2, because don't forget this will be a bit parabolic. And that gives me 0. Perfect. So it's a bit of trial and improvement, just working out what's closer. So again, using the factor theorem, what does this actually mean? Well, because this is true, f of minus 2 is equal to 0, then x plus 2 is a factor of f of x, which means we can now do our algebraic division. So x plus 2, and then we're using the good old-fashioned bus stop method. If you'd like, you can pause the video now and have a go yourself, but I'm going to go through it. So 2x cubed minus 7x squared minus 17x plus 10. Cool. So again, we start by dividing the first term by the first term in the divisor. So 2x cubed divided by x is going to be 2x squared. Then we times it by x again, so that's 2x cubed. And then plus 4x squared, because we did 2x squared multiplied by 2. Then draw our hopefully straight line. Subtract those two lines. So of course the first one always equals 0, which is, that's what's meant to happen. That's all good. Then we have minus 7x squared, and this is why I write the minus, remember? So minus 4x squared, so that's minus 11x squared. And then we just bring down the other two things because they're just subtracted by 0. Cool. Then we repeat the same thing. So 11x squared divided by x gives me minus 11x. Then times it again, we get minus 11x squared, and then minus 11x times 2 is minus 22x. Then we subtract it again. So this is very rhythmic. Okay, you do the same thing again and again. So of course the first terms cancel out. Minus 17 minus minus 22, that makes it a plus. So minus 17 plus 22 would be 5x. Then 5x divided by x is 5. Then times it by x again. Oh, I've got the plus 10 over here. And then that'll be 5 times 2 is 10. So as you can see, we get 0 because we should get 0, right? We know that x plus 2 divides into this expression perfectly, so our remainder has to be 0, otherwise we've done something wrong. So now what we have is that f of x is equal to x plus 2. And when we factorize out x plus 2, we're left with 2x squared minus 11x plus 5. Okay? Again, how would you work this out? Well, it needs to times to this number multiplied by this number, which is 10, right? So 2 times 5 is 10, so it needs to times to 10 and add to minus 11. So one thing that I'm thinking of, again, it adds to a negative number, but times is to a positive, which means they both have to be negative. So minus 10 and minus 1 would work. So we have x plus 2, 2x squared, minus 10x, minus x, plus 5. Then you split it down the middle and you factorize the first two terms and the last two terms separately. So factorize the first one. Out of 2x squared and 10x, I can take out 2. And I can also take out, so I'm actually going to put these in staple brackets, 2. And I can also take out an x. So that'll leave me with x minus 5. From minus x and plus 5, I can take out a minus 1. Generally speaking, you want this x to be positive, but also remember you need to make it match this bracket here. So I need to flip the sign by doing something cheeky like that. If you've done it correctly, these two brackets here should be duplicates of one another. And all you need to do is you put everything in front of the brackets, the 2x and the minus 1, in one bracket. And you put everything that's duplicated, x minus 5, in the other bracket. And that's it. For 6 marks, I think that's pretty reasonable. However, there are quite a few steps. Remember, the factor theorem is worth 2 marks, because that's what it was in the first question. And it's 4 marks for doing the division and then the factorization. Okay, so you get 2 for the division, 2 for the factorization. So 6 in total. It's not that bad, but it is kind of long and tedious. This question, we're actually given a few unknowns. So we have f of x is x cubed plus 6x squared plus px plus q. And then it says, given that f of 4 is 0 and f of minus 5 is 36, find the values of p and q. And that's for 3 marks, which I think is pretty generous. So how would you approach this question? Well, remember, they never give you useless information. So if you're ever unsure of what to do in a question, just use the information mathematically. They're telling me f of 4 is equal to 0, so why don't I write that out? They're saying that f of 4, which would be equal to 4 cubed plus 6 times 4 squared. All I'm doing is I'm subbing in 4 in place of x in this equation, plus 4p plus q should equal 0. Okay, now what I'm going to do is I'm going to work out what these two add to. So I'm just going to whip out my calculator again. We have 4 cubed, right, from the first bit. And then we have plus 6 times 4 squared. That's 3. 160. So we have 160 plus 4p plus q equals 0. So if I move that to the other side, so all of my unknowns are on one side, I get this. Okay, cool. And they also give me this information, f of minus 5 is 36, so why don't I use that as well? And I'm going to do the exact same thing that I just did, except instead of 4, I'm going to put in minus 5. But the actual steps themselves are actually the same. Okay. Minus 5p plus q should equal 36. Again, let's use our calculator to work out what these values are. However, make sure you use brackets because we have a negative number now. Although realistically I should have used brackets for the whole thing, but you know. 25, cool. So we have 25 minus 5p plus q equals 36. Minus 25 from both sides, we get minus 5p plus q equals 11. Okay, that's quite interesting. Now if you have a look, if I look at these two equations, they both have p and q in them. So they are actually simultaneous equations. So if I move these underneath each other, I can solve those simultaneous equations by subtracting them. So 4p minus minus 5p would be 9p. Q minus q is obviously 0. Minus 160 minus 11 is minus 171. So then p is just equal to 171 So minus 171 divided by 9, which, hold on, minus 171 divided by 9, minus 19. Cool. Then all we need to do is sub that into one of the two equations up here, and we can get our value for Q. So then we have 4 minus 19 plus Q equals minus 160. So 4 times minus 19, so we can literally just do times 4 if we want to, is 76. So minus 76 plus Q equals minus 160, which means Q is just equal to minus 160 plus 76, which is minus 84. Perfect. There you go, 3 marks. In my opinion, not that bad. Hopefully you can see where the logic lies. Again, this whole question is all about just writing out the information they give you and then seeing what you can do with it. Just writing out the information, by the way, gives you marks. The actual solving is 2 marks. So you get 1 mark for P, 1 mark for Q. But just doing this, where you substitute in the values, is a mark as well. So why not do it anyway? Get 1 instead of 0. Then it says factorize f of x completely. And if you notice, we already have the factor because they've already done it for us. So for part B, we know that x minus 4 is a factor. It's a factor of f of x. Just remember to keep flipping that sign, okay? So because it's plus 4 here, it's minus 4 in the actual solution. So all we need to do is do x minus 4 divided by this expression, and we're done, practically. Now let's see if we can fit it in. X minus 4, and draw a straight line. We have x cubed plus 6x squared. Now P was 19, so that's minus 19x, and this minus 84. Cool. This is also how we can check part A, because if it doesn't divide, then we know we've done something wrong either in the division or in part A. So x cubed divided by x gives me x squared. Then times it by minus 4, times it by x, we get x cubed. Times it by minus 4, we get minus 4x squared. Do the subtraction. X cubed minus x cubed is 0. 6x squared minus 4x squared. So we're adding, that would give me 10x squared. 10x squared divided by x gives me 10x. Then we have 10x times x would give me, don't forget also to write the other things, I'm being a bit sloppy here. 10x times x would give me 10x squared. 10x times minus 4 is minus 40x. And again, we're going to do the subtraction. That gives us 10x squared minus 10x squared is 0. Minus 19x minus 40x. Again, if you're unsure, you can just use that, but it should be 21x. And then the minus 84 is still there, of course. 21x divided by x gives me plus 21. And then timesing those both out, and as you can see, we get 0, which means we've done everything right in that question. It's highly unlikely that you do the question wrong and the division wrong, and yet you still get a 0 remainder. Right? That's very rare, so if you do get that, you should pat yourself on the back. So now we know that f of x is just equal to x minus 4, and then we have x squared plus 10x plus 21. So we're looking for two numbers that times to 21, add to 10. They're all positive, which means both the numbers are positive, and I'm thinking 7 and 3. So x minus 4, x plus 7, x plus 3. Not bad, right? Hopefully. So again, another style of question. So remember, the purpose of these worksheets is to try and give you an overview of all the different styles of question they can ask you. And then that way, whenever you go out into the wild and you find some questions, you'll be able to answer all of them. Again, if I've missed a type, then please leave it in the comments, and then I can add to this video or make like a little sub video. So again, use factor theorem to show that it's a factor. We are experts at this. So if x minus 2 is a factor, that means f of 2 should be 0. So I like to write out the equation just so the examiner definitely sees that I know what I'm doing, or at least I trick him into thinking I know what I'm doing. Then I just use a calculator to verify. Has it ever been where they've said show that it is a factor, but then it hasn't been a factor. Nah, not yet. But they might say, you know, check if this is a factor. But generally speaking, you can just write equals 0, and you should get a perfectly fine answer, although I've just said that and it's not correct. Oh, that's why I put... my finger slipped and didn't put the 14. There we are, 0. Kind of ironic, but yeah. There we are. And then it says, hence or otherwise solve the equation. Ah, okay, now this is where some people would get a bit confused. But remember, how do you solve equations? Yeah? You factorize them. So this question is literally just asking me to factorize. But if you notice, these parts are normally 4 marks. Now they've given me a 5th mark because I need to solve it afterwards. So if you go up, 4 marks for factorize. That's 6 because there's 2 there. 4 marks for factorize. Okay? The reason for that is because to solve cubics and quadratics, etc., you need to factorize. So just keep that in the back of your mind. You get 4 marks just for factorizing this, and then you're going to solve it. And there is a reason why they say give your answer to 2 decimal places. Do you remember back in GCSE when it said solve the equation x squared plus 2x plus 3 or whatever, and it said give your answer to 2 decimal places? It meant that you're going to have to use the quadratic formula. However, but remember, I've shown you on a calculator how to actually do that, so you don't need to worry about using, you know, the quadratic formula. So again, just so you're aware, all we need to do is do the division and then use the quadratic formula, or again use our calculator to solve it. So I hope that makes sense. But remember, to solve these equations you have to factorize. If you can't factorize, you use the quadratic formula, which is where it says 2 decimal places. It's a bit of a hint for you, but you should remember that from GCSE, I'm hoping. If not, there you go, now you know it now. But we're going to use our calculators for it. Anyways, I've said calculators now about 10 times, so I'm just going to start doing this division. X minus 2. Then we have 2x cubed minus x squared minus 13x plus 14. So 2x cubed divided by x will obviously give us 2x squared. Times by x again obviously gives us 2x cubed, which is exactly what we want. I know it seems like a weird redundant step, but that do be how it works. 2x squared times minus 2, so 2 times minus 2 is minus 4x squared. Then draw our little line, subtract. So 2x cubed minus 2x cubed, obviously 0. Minus x squared minus minus 4x squared, so we're doing minus 1, add 4. Okay, so that gives us 3x squared. Again, if you are ever unsure, just please use your calculator to work it out. Just do minus 1 minus minus 4. No one's looking at what you're putting in a calculator in an exam. You can do 1 and 1 if you'd like. No one's going to know. So, again, these last 2 terms, they just don't have anything underneath them, so we just drop them straight down. And that's why, again, keeping everything neat and orderly is quite important. Again, I know I'm not the neatest person, but I'm trying. 3x squared divided by x gives me plus 3x. Then we're going to have 3x times x, which gives us 3x squared. Then we have 3x times minus 2, which is minus 6x. Then we have nothing, so do our little line, subtract. Minus 13x minus minus 6 would give us, not plus 7, it would give us minus 7x. And drop the plus 14 down because there's no 14. Minus 7x divided by x is minus 7. Times it out again, minus 7x. And minus 7 times minus 2 is plus 14. See, I already made a mistake. Almost made a mistake right there, because that minus is a bit wonky. Let's see if we can just move it out slightly. There we are, that's much better. Cool. So now my equation for f of x is x minus 2, 2x squared plus 3x minus 7. And I'm trying to solve where it equals 0, but we'll get to that in a second. Now, if you remember rightly, I said you get 2 marks for doing the actual division, then you would get 2 marks for factorizing. But we're getting 5 marks here because we're actually giving numerical solutions. But it says we need to use the, well, it doesn't say this, but it implies that we need to use the quadratic formula because 2 decimal places. So because they haven't said factorize completely, I would just use quadratic formula slash the trick I showed you on the calculator where you can work out the answers to any quadratic equation. Okay? And the reason for that is, how do you know when you can or can't factorize? If I tried to test the factorizing on this, I'll probably be thinking for about 30 seconds or a minute trying to work out the numbers. Whereas if I just take them at their word, I don't need to. The other way you can kind of be aware of this is if they say solve, don't bother factorizing. Okay? So, for this to equal 0, either x minus 2 equals 0, so that means x equals 2, that's one answer, or this whole thing here equals 0, right? Those are the two options, because if they're in brackets, one of them has to be 0, because then they multiply each other to make 0, okay? So either x minus 2 is equal to 0, so x would have to equal plus 2, or this whole thing equals 0. So what I'm going to do is I'm going to solve that on my calculator. Menu, go right once, down twice to equation slash func, which by the way is why I recommend this calculator. The link to buy this calculator is in the description, so you can just go there like right now if you wanted to and buy it. And this is a polynomial, and our degree, if it's a quadratic, so x squared, the power of x squared is 2. That's what it means by degree. You're looking for the highest power of x. In this case it's 2, and we're just going to type that in. So 2 for the number in front of x squared equals 3 for the number in front of x, and minus 7 for the number square at the end. And if I press equals and then equals again, I get my answers. And can you see why now they've given me 2 decimal places? Would you guess that number for the factorizing? I wouldn't. So it says to 2 decimal places, so then we have, and x equals 1.27, and there should be one more, because cubics have 3 answers, negative 2.77. So you get an answer for each of those. Not too bad, hopefully. And again, you will get used to this over time, because you're going to solve so many cubics and quadratics that you're going to be doing it in your sleep, and they're going to haunt your dreams. So don't worry too much if that doesn't make sense, but I'm hoping that it makes a bit more sense than it did before. Lastly, the last type of question that you can be given is, hence show that it's the 3 is the only real root. Now, I know that there are some people that are going to scream at me in a second, but don't worry. First, use the factor theorem. Again, we know how to do that, right? If it's x minus 3 is a factor, you're going to sub in f where x equals 3. So again, we're going to put this in. This time I'm going to try and enter it in correctly first try. And minus 6. And let's quickly do this. So 4 open bracket 3 cubed minus 12 3 squared plus 2 3 minus 6. Hey, got it right first time, well done. Equals 0, boom, 2 marks. Again, where'd you get the marks from? You get a mark for subbing in the correct number. That means you know the factor theorem, right? Because if this is a factor, then the opposite should be what you sub in. And then you get a mark, obviously, for the actual substitution. Really nice 2 marks, and it will come up on your year 12 marks. I'm just going to promise you that right now. I've never seen a year 12 exam that hasn't had this question in it once. So, knowing my luck, that means this year is going to be the only year they've never done it, but whatever. This is hence show that 3 is the only real root of the equation. So remember, when you see root, in your brain, just sub in the word solution. So what they're asking us to do is solve this equation. But they're acknowledging that we might not get any solutions, which is totally fine. So, we're going to do the same thing that we've always done. We're going to do the division. This is the last one, just in case you guys are getting tired. And we'll be done DZ. And yeah, so I'll talk a bit about this question as soon as we've done this division, okay? But there is 2 ways of doing it. One way I haven't shown you yet because I'm doing another video on it, okay? Because it's a whole nother topic that's a bit more, it's not that bad, but it's like solving equations and stuff. But anyways, 4x cubed divided by x gives me 4x squared. Then we have 4x squared times x gives me 4x cubed. And 4x squared times minus 3 is minus 12x squared. Subtraction. Do it. Oh, they're both 0. That's really nice. That means we're just left with 2x minus 6. So 2x divided by x is 2. You know what? Forget everything I just said. You don't need to use what I thought you need to use. 2x minus 6 gives me 0. So in other words, my solution, or my partially factorized equation, is x minus 3 and 4x squared plus 2. Okay. And that should equal 0. So if it equals 0, we have x is equal to 3, right? Because this bracket should equal 0. Now, what about this bracket equaling 0? Well, there are two ways to do this. Now, one way is to use the quadratic formula and show that it will just say math error. You know, that's not the... In my opinion, it's not the nicest way. So instead, what I'm going to do is, if I want to make this equal to 0, this is a much more rigorous way of doing it. You say 4x squared plus 2 equals 0. Right, that's what we're basically saying. So minus 2 from both sides, we get 4x squared equals minus 2. Divide both sides by 4, we get x squared equals minus a half. Then you need to square root, so x is equal to... Well, I mean, you can't do it, right? So you'd say plus or minus the square root of minus a half. And you would just say the words not real. So that means x equals 3 is the only real solution. What do I mean by that? Well, those of you doing further maths or the CIE exam board, you should know that you can't square root a negative number because, I mean, obviously if I type in square root minus a half, what happens? Minus 1/2. Math error. If your calculator comes up with a quarter I, so the I letter, if you ever see that, that means you've got it in complex numbers mode. So just be aware of that. But generally speaking, you can't square root negative numbers. So yeah, there you go. It's the only root. That is a very quick question for 4 marks. And that brings us to the end of it. So once again, this worksheet is going to be available on in the link in the description. It's on Patreon, but again, it's completely free. It's just that hosting it there is way easier for me. If you spot any mistakes, if you think that different questions should be added, or if you have any questions, please leave them in the description. I also have a link to one of the 2 playlists which have all of my A-level maths lessons from last year. Okay? And yeah, they're a bit rough around the edges, but they're still like the content that's quite good. It's just that my camera quality was way worse, so I look very pixelated. But yeah, you can just enjoy those if you want. But other than that, I will see you in the next one.